So this is a good example. I think it might answer a lot of questions that you might be having. Okay, so in the numerator we have negative x squared plus 2x plus 4 over, now I want to start factoring that denominator. So first of all, there's a greatest common factor. You can take out x. And then this actually factors, right? Okay, so I get x times x minus 2. I'm going to write it squared. So x minus 2 times x minus 2 is this one, x squared plus minus 4x plus 4. I can write that if you want to see it. There. Anyway, you can FOIL it out or whatever. Okay, now we're going to set up the partial fraction decomposition. So I'm going to have one expression that just has a denominator of x. So it's like you're splitting up all these factors from the denominator. By the way, x, that's a linear factor, right? Because it's x to the first power. Okay. And then you're going to have a denominator of just x minus 2. Again, you can put parentheses around that. And then you're going to have a denominator of x minus 2 squared. So only this one's repeating, the x minus 2 factor. So we have it with it just once, and then we have it with it twice. Okay. Yep, that's that. All right, they're all linear factors, so the numerators are going to go A, B, C. Okay? Now, we want to remember this at the end. Okay. We have to remember at least the setup, over here, so we know where to put A, B, and C. Okay. Now what we do is we try to get that common denominator. So I'm going to have A over X. This is I already know what the common denominator is. It's that. So I need to multiply by x minus 2 squared. Okay. Plus B over x minus 2. Now, what do I have to multiply by to get this common denominator? I have to multiply by x and another x minus 2. And then the last one is c over x minus 2 squared. So what do I need to get the common denominator? I need x. Okay. Now we can kind of just, the numerators are all the same. You can look at those for a while. They're all that common denominator. Did I say numerator? The denominators are all the same, and they're that common denominator that we wanted. Okay, so let's just look at the numerators. I'm going to have negative x squared plus 2x plus 4 is going to equal this, which is going to be a times x squared minus 4x plus 4. You have to think about multiplying that out, but that came from up there. Okay. Plus, and then I'm going to have bx times x minus 2 plus cx. Okay, so now I have to do a little bit of distributing here. So I get ax squared minus, now here's how you're going to write this. It's going to be 4ax. So you put the coefficient and then the a, b, or c, and then the x. Okay, plus 4a. Then here I'm going to have bx squared minus 2bx. And then finally I have plus cx. Okay, now here's where the fun comes in. So it's like a matching game. You have a negative x squared, right? So that negative x squared has to equal anybody that's an x squared term. So ax squared plus bx squared. Now you don't really need the x squareds. You're going to say negative 1 equals a plus b. Okay? So that term that I underlined in green and the other term I underlined in green, those have to add up to be negative 1 x squared. Okay? All right. Now we're going to look at the x term. 2x has to equal, okay, any term then that has an x in it. Negative 4ax minus 2bx plus cx. Those are all my x terms, right? You don't need the x, so you can just write 2 equals negative 4a minus 2b plus c. So, yep, there we go. All right, I'm almost done. And then the last one, you have a constant, 4. Well, I only have one term left. Right here, that's a constant because there's no x in it, right? So it's just 4a. Okay. Now, we have what's called here a system of equations. We have this equation, and this equation. And maybe I shouldn't have put a box around them, but what we're going to say is, working with those three equations, we can find a, b, and c. This one's the easiest one. You probably noticed that. Divide both sides by 4, a equals 1. Great. Now I'm going to go to the second easiest one, this green one here. And I'm going to say negative 1 equals, I just figured out what a was, 1 plus b. So b equals negative 2. And then now I can do the third, the longer equation here. And I know what a and b are, so 2 equals negative 4 times negative 2 minus, oops. I did that wrong, didn't I? Darn it. Okay, let's start over. 2 equals negative 4. A was 1. Minus 2 times b was negative 2 plus c. We don't know what c is, but we're going to figure that out in just a minute. And it looks like c is 2. Okay. So now remember I said, oh, we need this later. Okay, now we need that stuff way back at the top. A, b, and c. So it's this part right here to write the decomposition. So a over x, b over x minus 2, and c over x minus 2 squared. So I think that's what it was. I'll recopy it in orange. You'd have to scroll up to see if I'm writing it right. I'm pretty sure I am. Okay, now what was a? It was 1, wasn't it? Yeah. All right, so 1 over x plus negative 2 over x minus 2. Now, if you have a question about that, like I wrote 1 over x plus negative 2 over x minus 2, you could write 1 over x minus 2 over x minus 2. Generally with these, they don't. They just usually use the addition symbols, but, they could. Plus, and then what was my c? 2? Okay, so that's the partial fraction decomposition right there. So we figured out what a, b, and c was, and we wrote the decomposition. And you might be saying, why would you want to do this? Well, in calculus, at one point we say, oh, we need to split this up so we can do, I think an integral is what we use it for. But anyway, that's what we do, partial fractions.